Okay, so we start Unit 5, I think, is today. I think is where we're up to. Mean value theorem. And so to me, I think the concept for mean value theorem is really not that difficult. And I'll try to drill that over and over again, and then we'll make the jump to the details of using the mean value theorem and using the calculus and the math and the algebra that goes with it. So let's start with the concept. We got our little guy here driving a funny little car. I doubt he could go 72 miles in 1.2 hours. Thank you. But what would his average speed be, or how would you find his average speed if he drove 72 miles in 1.2 hours? How do you find average speed? Yeah, just divide 72 miles over 1.2 hours. Someone last period was like, safe stop. Like, yes, that's true. That is a safe stop. You could stop there. But it would kind of mess up the rest of the problem. So let's go ahead and divide. 72 divided by 1.2 is 60 miles per hour. So if you travel 72 miles in 1.2 hours, your average speed was 60 miles an hour. Does that mean you drove 60 miles per hour for the entire drive? No. Right? Like sometimes you were faster, sometimes you were slower. Who knows? But you're definitely not 60 the whole time. Does it mean that at some point during your drive, you were driving exactly 60 miles an hour? That's the key question. That's the MVT question of the day. Why is it yes?
Because you start at 0.
Okay. So you started at 0, which means, so for part of the time you were definitely below 60, which means part of the time you got to be above 60. And then here's the key thing, you couldn't jump, right? You couldn't be going 58 and then all of a sudden be going 62, right? Even if your car accelerates really, really quickly, you can't make the jump. Like it's got to be what's the math word I'm looking for there? To get from 58 to 62, it's related to IVT. There's a continuous element in there that you got to pass through 62 somewhere, or 60 to get to 62. So it's definitely related to that. Even if you didn't start at 0, so like let's say you started this timer after you had already left your house and you've been driving for a little bit, it's kind of the same thing. Even if you started your trial when you were going 55 miles an hour, well, at some point you had to be going more than 60 miles an hour to balance it out. So at some point you were going 60. Could there have been, I think there's missing a word in there, could there have been more than one time during your drive when you were doing exactly 60? Yeah. In fact, yeah, you could like set the cruise control at 60 and have it for a lot of times going 60. But there had to be at least one time when your instant speed, that's the speedometer, was equal to your average speed. That's where you do the calculation. This is the mean value theorem. So in non-mathy words, instant speed equals average speed. That's what the mean value theorem tells us. That somewhere, I guess we should say that, somewhere instant speed equals average speed. Now, if we want to change that into a little bit of, actually, let's leave it for now. We won't get to calculus just yet. Your instant speed is your speedometer, right? Whatever the speedometer is reading. Your average speed, that would just be like the odometer over time. Right? Like you went 70 miles in 1.2 hours. You divide, that's old school algebra type stuff. In fact, that's an algebra type of slope. y2 minus y1 over x2 minus x1. An instant speed, that sounds more like a calculus slope. So this is how I remember MVT. Calculus slope equals algebra slope. somewhere. That's sort of in parentheses there. Like, I don't know where it happens, but somewhere your instantaneous calculus slope equals the overall algebra slope. That's the MVT sort of concept. Average rate of change, that's the slope between 2 points, delta y over delta x, or y2 minus y1 over x2 minus x1. That's what I've been calling the algebra slope, like algebra 1. Instantaneous rate of change, slope of the tangent line, slope at a point, dy dx, that would be what I've been calling the calculus slope. So, mean value theorem says that given the right conditions, we'll talk about those in a little bit, with the right conditions, the instant slope equals the average slope. The calc slope equals the algebra slope. If you want to use the abbreviations, the IROC equals the AROC, instantaneous versus average. All of those are saying the same thing. So whichever one your brain kind of locks onto to remember MVT, like, you don't have to remember all of those. You just got to remember one of them. The one I like is calculus slope equals algebra slope. That's the one that makes the most sense to me. I think because it's a kind of a combination of a concept, but there's a little bit of a equation sort of built into that. You know what algebra slope is. You know what calculus slope is. So we'll set them equal to each other. Let's see if we can draw a picture and sort of convince ourselves that this is true, not just for some guy driving around in his car, but for a graph. So it works for any complication of graph, but just to make our picture easy, let's do a kind of an easy graph. Let's say our first point is down here at A, and our second point is over here at B. And I guess let's just follow right along with what we've been writing here. The average rate of change, that's the y2 minus y1 over x2 minus x1. So in this particular picture, my y's would be f of b minus f of a, the function at b minus the function at a. We really want to label them. Over b minus a. And if this graph is f of x, then the IROC, the calculus slope, I don't have an equation for that, so I'm just going to call it f prime. And that's true somewhere on a to b. So somewhere in that interval, the calculus slope is equal to the algebra slope. I'm grabbing popsicle sticks, but not the ones you're afraid of. Different ones that I've labeled. There's my algebra slope popsicle stick. I'm just going to use that to connect the dots. All right, that's M. That's algebra slope. So this MVT tells me, and my graph shows that somewhere, right, parallel means same slope means parallel. So I put my other popsicle stick on there parallel and move it around until it lands, meets the curve, looks like right about there. So right about there tangent line, f prime. So now I've got a calculus slope equals the algebra slope, and where it happens is, we usually call that point C, the place where it happens. But that point will always be between A and B. So on the interval, somewhere the calculus slope is equal to the algebra slope. The overall slope is equal to the instantaneous slope. The I rock is equal to the A rock. You can label it 100 different ways. Average rate of change over the whole thing equals the instantaneous rate of change at some point. Okay. A car that is equipped with the easy tag. You know what? Let's box this in, because this is that's the conclusion there of the MVT. That's sort of the fancy way of saying that calculus slope equals algebra slope. I don't memorize this. That's a lot of stuff to memorize. I memorize calculus slope equals algebra slope, and then I can come up with that. Because I know what calculus slope is. I know what algebra slope is. Okay, a car that is equipped with an easy tag drove through a toll booth at mile marker 226 at noon. Time, miles. I keep them. Anytime that I see a lot of data coming, I'm going to try to organize that. So at noon, we were at mile marker 226. Then through a toll booth at mile marker 326 at 1:15. The speed limit is 70. A few days later, the driver received a speeding ticket in the mail. How did he get caught speeding? Should this hold up in court?
Would they actually do this?
So, do they actually do this? I don't think they do, because I feel like a lot of people would have gotten tickets if they did and would be complaining. Right? Around the Beltway or around 99, some of you are nervous, wait a minute. But there is something, I need to go find it because it made the rounds among calculus teachers. On the big bridge in Louisiana, apparently they do this, and they made a big deal of it, and so all the calculus teachers are like, hey, MVT, they're using MVT. And so I don't think the Houston toll areas use this, because I think a bunch of people would have been busted with tickets already. Probably me included. But yes, you're onto something. They could, if they wanted to, they could do this. There you go. Okay, well let's see if he's guilty or not. So we don't know. This is the whole point. Nobody put a radar gun on this guy, and so nobody knows what his exact speed was at any point. You don't know. There weren't any police there at all. But his average speed we can get. His algebra slope, 326 minus 226 over, I need to be careful here. I don't really want to do 1:15 p.m. minus noon. That doesn't make much sense. What's that time difference in hours? 1.25. Right? 15 minutes is a fourth of an hour. So this guy made 100 miles in 1.25 hours, and if you don't have a calculator or don't want to do the math, that's 80 miles per hour. So you're thinking, well, that's not terrible, but it's definitely above 70. So how did he get caught speeding? The algebra slope, that means somewhere his velocity equals 80. It probably also means that there were times he was more than 80. And if there were times, like if he was 80 the whole time, that means he was over the speed limit for an hour and 15 minutes. However you think about it, whatever his speed was, at some point, a lot of points probably, he was more than 70 miles an hour. So, yes, he got caught speeding by MVT. Should this hold up in court? Yes, it should. Somewhere his velocity equals 80. And that somewhere was between noon and 1:15. Like that seems obvious for this problem, but later on, that between noon and 1:15 part will be more important. Okay, we've been looking at the conclusion of MVT. We need to look at the, not the circumstances, but the conditions. Like when will it work versus when would it not work. And here's when it would work. If f of x is continuous and differentiable, then this will work. So it must be continuous on the closed interval, continuous on closed, differentiable on open. And by the way, in any time you need something to be continuous, it'll need to be continuous on the closed interval. Anytime you need something to be differentiable, it'll need to be differentiable on the open interval. So that gets kind of confusing as to who goes with who and where, but it's always that combination of things. So continuous on the closed, the C's go together, differentiable on the open. So if the derivative doesn't exist at the endpoints, that's okay. But it does have to be continuous at the endpoints. In fact, here's trying to write it a different way. Here's our if statements, those first two stars. If the function is continuous on the closed, and if the function is differentiable on the open, then our conclusion is that calc slope equals algebra slope, or IROC equals AROC, somewhere. Here's one more way to think of it. We had done IROC and AROC, then calc slope and algebra slope, did the formula, but here's dy dx and delta y, delta x. Again, that's just more ways to say AROC versus, or IROC versus AROC, calculus versus algebra. It's just another way to remember it. Usually the questions are, usually what we ask is, where does it happen? That's usually how we ask the question. So does MVT apply? If it does, where? Where was he going 80 miles an hour? Now, we didn't have enough information to answer that on that last question, but if I had an equation, then I could figure out where he was going 80 miles an hour. All right, example 1. If g of x equals x to the 2/3, find all values of c which satisfy the mean value theorem on 0 to 8. Okay, before we get to the mean value theorem, we have to worry about the if parts. So we have to think of this as like a checkbox here. Is it continuous on closed? And is it differentiable on open? If I can check those two boxes, then I can go to the rest of the problem. If I can't check one of those boxes, then the problem's over and MVT doesn't work. Which we kind of like those problems better because it means you don't have to do anything. But you always have to check because sometimes it won't work, and again, you like those because your problem's over at that point. All right, you're probably not super familiar with what x to the 2/3 looks like, so I'm going to give you the graph, and then I think we'll be able to answer those two questions. Let's see, x to the 2/3 looks a little bit like that. Okay, so just looking at the picture, is that thing continuous on 0 to 8? Doesn't really matter where 8 is, but out there somewhere. Is that thing continuous on 0 to 8? Yes, definitely. In fact, it's continuous everywhere. So I'm not worried about continuity. Is it differentiable everywhere? No, why not? There's a cusp. Where is that cusp? At 0. So is it differentiable on the open interval 0 to 8?
Yes.
Yes, because we've excluded 0. 0 is a problem, but I don't care about 0. 0 is not on this interval. So the only cusp is outside the interval. Or like the interval that we care about. So yes, there's a problem, but it's not where we're looking, so it's okay. Like we're not worried about it. Okay, once we can say those two things, then we can say MVT applies. Which I don't know if that's good or bad, right? If it didn't apply, we'd be done with the problem. But it applies, so that means that somewhere the calculus slope, again, this is how I start these problems. You can start them at any of those phrases we used. You can start it with IROC equals AROC. You can start it with dy dx equals delta y over delta x. You could just start it with the formula. Okay, so now I've got to find the calculus slope and I've got to find the algebra slope. I think I'll do the algebra slope first because that feels like it should be easier. So from 0 to 8, I need the y value at 8 and the y value at 0. And then I'll plug those in, and then it's an Algebra 1 question. Eight to the 2/3. Speaking of Algebra 1 questions, put the pressure on Danny. 8 to the 2/3. The bottom number is the roots, the top number is the power, flower power, 4. So the cube root of 8 is 2, and 2 squared is 4. Cube root of 8 is 2, 2 squared is 4. And then, well, Callie gets the easy one. 0 to the 2/3? Add a 0. So I'm trying to save space over here. y2, I'm going to go 4 minus 0. That's my change in y. My change in x is 8 minus 0. So that's 1/2. I suppose if I wanted to draw the picture, there's my algebra slope is 1/2. And I can tell by looking at my graph that the MVT does work. There's a spot on the graph about right there. Now, about right there isn't really the answer we're looking for, but about right there, the calculus slope, the instantaneous slope, is equal to 1/2. So my job is to figure out, well, where is this point? Other than looking at the graph and saying, it's right there. How do I get the derivative of x to the 2/3? What's that equal to? Power rule experts. Don't make me pick on somebody. Audrey, what's the derivative of x to the 2/3?
2/3 x to the negative 1/3.
Nice. 2/3 x to the negative 1/3. That's kind of ugly. I don't like negative 1/3, so I think I'll change that to a cube root of x in the denominator. Now it's an algebra problem. Calculus is over, but doesn't mean it's easier. I think I'm going to multiply both sides by cube root of x to get it on the right, and multiply both sides by 2, so that I'll have the cube root of x equals 4/3. I'm running out of space. I'm going to cram up my algebra here. So what should I do to get x by itself? You can just set those on that desk right there. So what should I do to get x by itself? Cube it. So x equals 4 cubed over 3 cubed, or just 4/3 cubed, I guess, which would be a safe stop. Except that I kind of want to make sure that that's between 0 and 8. And I don't know if 4/3 cubed, if I can tell that just yet. So 64 over 27, that is between 0 and 8. I knew it should be. So that's my answer. At 64 over 27, the instantaneous slope equals the average slope. The calculus slope equals the algebra slope at some point between 0 and 8, because my original function was continuous and differentiable. I think still no calculators yet. Number 2, h of x equals x plus 2 over x minus 1. Before we go any further, what's going on with x minus 1? What's that mean? What does that mean for the graph? You pre-cal experts. There's a vertical asymptote at x equals 1. So that could be a problem if 1 is in the interval. If 1's in the interval, this problem is done. I can't handle a vertical asymptote. How many values of c are guaranteed by the mean value theorem on the interval 0 to 3? Well, is this thing continuous on 0 to 3? No, it's not continuous on 0 to 3, because there's a vertical asymptote at x equals 1. So we like that. That means the problem's almost over. We need to clarify what's going on. So MVT does not work. It does not apply. I didn't even make it to the second condition. It just doesn't work here. So let's answer the question. How many values are guaranteed by the mean value theorem? What do you think the answer is? None. Mean value theorem, if it works, guarantees at least 1. If it doesn't work, then obviously it can't guarantee any. No value is guaranteed. Because MVT didn't work. Because it wasn't continuous. Alright, number 3's got a lot of space to work, so one suspects that maybe it will work, and we'll have to do some work on it. Find all values of c guaranteed by the mean value theorem for y equals cosine of x. Okay, so the question I'm asking myself is it continuous on 0 to 4 pi? And is it differentiable on 0 to 4 pi? Although continuous on the closed, differentiable on the open. Maybe we think about the graph of cosine, and even if you don't know it perfectly, you probably know it well enough to answer these two questions. Is it continuous on 0 to 4 pi? Yes or no? Yeah, because it just goes up and down. Now, if you want to be a little more precise, it starts at a max, right? Ends at a max. That's one cycle of cosine. Apparently, we want to go to 4 pi, so we need another cycle of cosine. So yes, it's continuous on 0 to 4 pi. How about differentiable? Is there anything that would make it not differentiable? I'm looking for a cusp, or a vertical tangent line, or a jump, or something weird. There's nothing weird going on. So yes, it's differentiable on 0 to 4 pi. Therefore, MVT applies. Again, you can jump to the formula, or you can jump to one of those other statements. To me, I always remember calculus slope equals algebra slope. Again, if you want to put one of the other formulations right there, IROC equals AROC, dy dx equals delta y over delta x, instant slope equals average slope. All of those are equal. They all mean the same thing. Okay, calculus slope equals algebra slope. What's the calculus slope? Negative sine of x. In fact, you know what? I should probably say calculus slope equals algebra slope somewhere on 0 to 4 pi. And that's kind of the point. It's like, well, where does it equals? Algebra slope. So I need the algebra slope. So I need the y value at 4 pi and the y value at 0. So the cosine of 4 pi. I can get it from the y-x graph, but I could also get it from the unit circle if you're thinking like that. What's the cosine of 4 pi? 1. And the cosine of 0, it's the same spot on the unit circle, so that's also 1. So 1 minus 1 over 4 pi minus 0. So negative sine of x equals 0. So I need to figure out where the sine equals 0. Well, looking back at my unit circle here, that happens at, I mean, 2 pi is one of them, but there's a lot of other places. Where is the sine equal to 0? Wait, sine is the up and down one, so I don't want those 2 points. I want these 2 points. So 0 and 2 pi is right, but there's something in between 2 pi. Pi. And I've got to be thinking about going all the way to 4 pi. So 3 pi, and 4 pi, and 5 pi, and on and on and on. Although I can throw out the 5 pi because he's not on my interval. And then this one's tricky because it's checking my the endpoints. And so if you go back to the original statement, there must exist at least one number on the open interval, meaning I'm not allowed to use my endpoints. So I probably shouldn't have drawn that arrow. I should have said on 0 to 4 pi. You're not allowed to have an endpoint for an answer. So I got to throw out 0 and 4 pi. Because those are not in my interval. I just barely missed it. So pi, 2 pi, 3 pi. Thank you. Are on the interval from 0 to 4 pi. The open interval. Oh, I didn't do my picture thing here. The algebra slope, that would be from start to finish. That's definitely a slope of 0. That's my average slope. And where the calculus slope is 0 is right there, and right there, and right there. I guess if I really knew the graph, I might could have answered this question off the picture. If it's continuous, and if it's differentiable, then calculus slope equals algebra slope. Okay, number 4, we got a table. Right, good news and bad, right? I won't need to know derivatives of equations because there aren't any equations. I'll just have to get my values off the table. Selected values of f and g are given in the table. F and g are both differentiable functions. If they're differentiable, what else does that tell us? So that means f and g are continuous. Okay, so I'm definitely set up for MVT over any range. If they're always continuous and they're always differentiable, then I don't have anything to worry about. So I can jump straight to calc slope equals algebra slope and figure some things out in here. Explain why there must be a value of x such that f of x equals 0. Why does f of x equal 0? Well, maybe it might be easier to say, where does f of x equal 0? Between 1 and 3. You're right. F of x equals 0, like somewhere in here, because there's got to be a 0 in there somewhere. Do you remember what kind of problem this is? This is an IVT problem, an intermediate value. This is not an average slope thing. This is just IVT. So for IVT, it doesn't matter about cusp. It just has to be continuous. So I'm not worried about differentiable. So f of x is continuous. It's continuous everywhere, so I can just say continuous. And then the IVT format is, if the y value is between the y values, then the needed x value has got to be between the x values. So the y value is 0. That's in between -2 and 5. Many of you on not the most recent test, but the one before that, remember I said you could do either one of those and you're saying the same thing? Many of you did both, which is, I think, good, because the first statement, it's clear, yes, 0 is in between -2 and 5. The second statement, though, kind of attaches some x values in there, and that's where we're headed. So there must be an x on 1 to 3 where f of x equals 0. Which is what you said from the very beginning. You're like, it's got to be in between 1 and 3. Like, yes, now puts the appropriate calculus behind that to show that. All right, so all of that was an IVT problem. That was just to making sure we're on our toes there. Part B. Explain why there must be a value of x in 4 to 9 such that g prime. So pretty sure this is not an IVT problem, but an MVT problem. Because we want to know that the derivative, the slope, is equal to 1. Okay, well, MVT means I've got two if statements. I'm just going to satisfy them both at once. G of x is differentiable. That was given to us. And therefore continuous. So MVT applies. Yay, I can work the problem. Although, again, if it doesn't apply, that also means you don't have to work the problem. MVT, that's calculus slope equals algebra slope. All right, calculus slope for G. I don't have an equation for G, so how do I represent the calculus slope of G if I don't have an equation to take a derivative of? It's almost just a notation thing. How do I say the calculus slope of G, which is G prime? So G prime of X equals, and that's kind of where we're headed, the algebra slope. And I'm guessing the algebra slope is going to be 1, but let's figure it out. So G of 9 and G of 4. Put people on the spot for that. See if Macy and Kinley know how to read a table. So, Macy, how about G of 9? $12. Kinley, how about G of 4? 7. And this might not be the best example problem, because if you messed up F and G, you'd still get the same thing, so shame on me, I guess. But yeah, 12 and 7. So algebra slope is y2 minus y1 over x2 minus x1. And I don't know that that's really a safe stop in this particular problem, because you're trying to get the answer to be 1. So yeah, that equals 1, but you need to make sure that I know that you know that that's 1. So yes, the slope equals 1 somewhere on 4 to 9 because of MVT. Yeah, I mean, that's exactly what they said. Show that that's got to be true. Well, MVT says it's true. All right, last one. Explain why there must be a value of C on the interval 1 to 9 such that f prime is equal to 4. This looks a whole lot like the problem we just did, although there is a twist coming. F of x is differentiable and continuous, therefore MVT applies. We have to say that. If we're going to use MVT, we got to check mark the two boxes. It's differentiable, it's continuous. Okay, well, if MVT applies, that means the calculus slope equals the algebra slope. Some of you are not going to write that statement at all. Some of you are going to write IROC equals AROC, dy dx equals delta y over delta x. Many of you will probably just say, forget that, I'm just going to write f prime equals and then fill in the algebra slope. So I need f of 9 and f of 1. So Zainab and Naomi can help me with that. F of 9 is 12. And Naomi, f of 1 is negative 2. So 12 minus negative 2 over 9 minus 1. Wait a minute, 14 over 8. What was I expecting to get here? 4. I got 14 over 8. Okay, so that means on 4 to 9, the slope I'm guaranteed is 14 to 8. 14 over 8, 7 over 3. So maybe I need to try a different interval to hopefully land at 4. So this is kind of a pain. Now I've got to find the slope maybe for every possible combination of points up there that give me a slope of 4. So let's see. From negative 2 to 5, that's going to be a 7. That's not going to be it. 5 to 7, 3 to 4, that slope would be 2 over 1. It's annoying when they give you problems like this because you have to keep searching for a slope of 4 and then you can work the problem. That slope would be negative, so that's definitely out. That would be negative 3. How about from 4 to 12, 7 to 9? Yeah, because that would be 8 over 2. Okay, so let's use those points now. So on 7 to 9, looking up at my table, 12 minus 4 over 9 minus 7. That's 8 over 2, that equals 4. So that means f prime equals 4 somewhere on 7 to 9. So that was kind of cruel. 7 to 9 is within 1 to 9, so it still works, but they made us go find all those slopes until we found one that equals 4. They don't do that very often. If they do, you won't have that many points to test, because that's a time waster thing. Almost always start with the points they give you, and usually that will work. Alright, I'm going to give you worksheet 1 in just a second. Let me summarize as briefly as I can. If it's continuous and differentiable, then I rock equals A rock, or calc slope equals algebra slope. Okay, there's the lesson in one brief statement. But you know what? We always leave off the word somewhere, and that's important because that's usually the whole point of the problem, is figuring out where does that happen. Check the two conditions. Is it continuous? Is it differentiable? If it's not, you like those problems because then you're just done. If it is, which will be most of them, then you have to figure out where that happens.